Good morning. Happy Wednesday. I hope everybody is having a glorious middle of the week and getting into the week and getting used to the weekend, getting excited that it's almost Friday. let's call it what it is. My name is Kobe Flatt and this is the MAP4C Grade 12 for Foundations for College Mathematics course. If you were with us yesterday, we started lesson 13. Today we are going to be continuing and finishing off lesson 13 today. We are right in the middle of our 6th week of our 9-week radio Zoom schedule. We have today's class, tomorrow's class, and then a long weekend. On Monday, our office will be closed. There will be no classes broadcast on Monday, October 13th, as we will be observing the Thanksgiving holiday. Classes will resume as normal on Tuesday, October 14th. So just putting that in your calendar now, there is no class on Monday. Tuesday, all the regular scheduled classes. So we'll have MAP4C back on Tuesday at 10, and then PLAR History Geography at 11. We've got our ENG4C going on air at 2 o'clock, our language class at 3, the literacy course at 4, and math happening at 5 and 6, finishing with our environmental science at 7 o'clock. So Monday's the holiday. Tuesday will be resumed classes, shortened week, and then it's just 2 weeks after that and the term's done. So we're really rolling now, flying along. On that note, let's pick up where we left off on lesson 13. We're still looking at imperial and metric measurements and conversions. We're going to continue exploring the differences in both systems. We will further grasp how to convert measurements within and from one another, the different measurement systems. We looked yesterday at converting within. We really went through the metric units, seeing how the metric system is based on units of 10. We really played around with those steps and moving of the decimal, whether we were supposed to multiply or divide, move the decimal to the right or to the left. Today we're going to jump into converting between the two systems. So how do we go from imperial to metric and metric to imperial? How do we get the conversions right so that we don't end up in another Gimli glider scenario where we miscalculated? Yes, that was an extreme example. When you need to convert between any two systems, it is always wise to set up ratios. So whether you're converting currency or temperature or whatever it may be, set up ratios. If you look on page 21 of your Unit 3 course material, you'll see this know and need chart. Whenever you want to convert between systems, create a know and need chart that can resemble what this ratio system looks like. So when I say set up ratios, this is what we're talking about. Say we need to convert 3 feet into inches. We want to know how many inches are in 3 feet. What you would do is you would create this know and need chart. Looking at the know and need chart on 21, we're just going to copy that out. It's like making a tic-tac-toe board. We're going to put know, that's K-N-O-W, because we want to know. Then, so you make your tic-tac-toe chart. In the far right square, you're going to put need. And this is how we're setting up ratios. So I'm going to show you how it looks with the know and need chart. In the middle, we've got, if we're looking at our tic-tac-toe board, we have the top row, know, on the far left. Then what we're doing is we're putting our units and our need in the top right. So in this case, because we're converting 3 feet into inches, our units are feet and inches. Now if you look at the little note here, it says remember to put what you know on top. So we know 3 feet. Feet is what we know. We're given 3 feet. So we're going to put feet on top, and that means inches goes underneath. So what do we know? We know that 1 foot is equal to 12 inches. That's our know column. So when you're looking at your tic-tac-toe board, you have know in the top left. In that middle left side box, we have 1 foot, because our units are in that middle column. We know that 1 foot is equal to 12 inches. So the bottom row, which is inches in that middle there, the bottom left, we're going to write 12. What we need is how many feet convert to how many inches. Excuse me. In our example, we have 3 feet. So we're going to put 3 feet in that middle row on the right box. And what we're trying to find is the inches. What we're doing is we're putting what we know on top. We know the feet. That's what we're working with. Convert 3 feet. So we know 1 foot. We want to find 3. Or we have already 3 feet, I should say. And then underneath is we know that 12 inches are in 1 foot. So how many inches are in 3? So this is what it can look like. And these are the ratios that I'm talking about. You can put it in this chart, or really what it is translating to is 1 foot is 12 inches. So 1 divided by 12, 1 over 2, is equal to 3 feet over X amount of inches. So these are our ratios. 1 over 12 equals 3 over X, because X is our unknown. Instead of putting, you can put a question mark, you can put a symbol, you can put a question mark, you can put a smiley face, you can put a sad face, because we don't know it. You can put X. In math, we use these variables. So we're plugging X in as our unknown. And then truly all we're going to do is cross multiply. So we take our 1 foot from that no side, from that 1 over 12, 1 foot, and we're going to cross multiply down so that we get 1x. Multiplying, you put them together. Remember, you can write multiplication as 1 times 6 with a little dot in between. 1 times 6 with the x in between, the symbol that we know as multiplication. You can put 1 open bracket, 6 close the bracket. That means 1 times 6. You can put both of them in brackets, the 1 and the 6, and it means 1 times 6. When we're dealing with numbers, you need all of those brackets, because if I just smush them together, 1 times 6, it just looks like 16. But when you have a variable, a symbol, a letter, you can put them together. X. Oh, that's a really messy looking X. We're going to get rid of that. You can put them together because there is no such number as 6x. So we say we're going to multiply. We can tell that. So when we're multiplying 1 times x, we get 1x because we're smushing it together. Then you cross multiply the second ratio. So we have 12 left on the bottom underneath the 1. And we're going to cross multiply up across to the 3. So 1x equals 3. Now we have to use our brackets. Remember, we can't smush them together because they're letters, or they're numbers, not letters. If we smush it together, we would get 312. We don't want that. So 1x equals 3 times 12. Now, that 1x, we want to get x by itself. Like we've done before, you would divide out the x. So you divide out the 1 because we want the x to be the same. We want the x to be on its own. We want to get x by itself. Right now it's attached to the 1. You divide it out, cancels it out. That leaves us with just x. X equals 3 times 12. 3 times 12 is 36. Therefore, x equals 36. So we know, therefore, there are 36 inches in 3 feet. So you can set it up in the chart, or you can just set up the ratios. Because all we're doing is, I'm going to see if I can use, oops, let's see here our laser pointer. If we take this box, we take this, the 2 left-hand side squares of our tic-tac-toe board, and what we're seeing is 1 over 12. So we just wrote it over here, 1 over 12. Then over here, if you look at our tic-tac-toe board, we're actually showing 3 over x. We have our line here, and so we just wrote 3 over x. So you can copy the whole tic-tac-toe board chart, or you can just set up your ratio 1 over 12, 3 over x. And then you cross multiply. So let's try a little bit harder ones. And you can set up the whole chart if you want, or you can just set up ratios. Here we go. Example 1 says convert each length. A van is 17 feet long. We want to convert feet to meters. I have over on the side of the board our cheat sheet of imperial to metric conversion and metric to imperial conversions. So what we're going to do is set up our know and need. Remember, know is on the left, so we know that 1 foot is equal to, and all we're going to do is look over at our meter. So 1 foot, it says here, from the imperial to metric conversion chart, 1 foot is 0.3048 meters. So we can say 1 foot is our know, K-N-O-W, 1 over 0.3048. And that's equal to, now we need our need. Well, we have 17 feet at the top, and you can do FT, you can do that one little hash tick mark that also represents the unit feet. Over, we don't know. We need to convert to meters. So this is our x. It's our unknown. X meters. All we're going to do is cross multiply. We're going to cross 1 multiplied by x, and then our meters by feet. So we have 1 times x equals 1x. 1x is then equal to 17 times 0.3048 meters. Now you can see that I did 17 first. It doesn't matter with multiplication which one comes first. I could write is equal to 0.3048 times 17. That part doesn't matter. When you're multiplying, it goes either way. It's okay. So we want to find what is 17 times 0.3048. We get 5. So either way, whichever way you write it, 1x equals 5.1, we'll round 8 meters. You can keep that 1x. That 1x, remember you divide by 1, x equals 5.18 meters. So therefore, I did not give myself a lot of room in here. Therefore, 17 feet is equal to 5.18 meters. Always include your units of measurement. I realized when I did that over here though, when I wrote it in my ratio XM, that's kind of confusing because it looks like we have two variables. Not what I meant to do. I just like to highlight what our units of measurement are. But for this sake, we should just say X so that it's not confusing. But always in the end, write your units of measurement so that we know whether it's a dollar sign or feet or volume, whatever it might be. Make sure you're writing your units. All right, let's try the next one. A regular soccer pitch must be between 90 meters and 120 meters long. Convert that to feet. How many feet would a regular soccer pitch be? Make your know and need. We know that 1 meter is, look over at our side, 1 meter, here we have 1 meter is 3.2808 feet. Again, I did that 1 meter. You don't have to put that M there if it's going to be confusing. If it's going to be confusing, you can just put the 1, whatever is going to work. 1 meter usually works for here because it's not until we get to our unknown, the need for our X. So first what we're going to have to do is, if it's got to be between 90 meters and 120 meters long, we're actually looking at two different measurements. So when you're thinking of your soccer pitch, it's kind of a rectangle. It's 90 meters by 120 meters. So first then let's look at the width. What is 90 meters? So we have 90 over x. X is our unknown. We're going to cross multiply. 1x, you can also just put x. 1x is just 1x. You can just put x. Equals 90 times 3.2808. X equals, what is 90 times 3.28, oops, decimal, there we go, 2808. Oh my goodness. 2808. Haha, there we go. We get 295.275. So we're just going to say 295. So 90 meters is equal to 295 feet. All right, that's the first width. Now, let's do the second. 1 meter is equal to 3.2808 feet. So 120 meters is equal to x. Let's find out. Let's cross multiply. 1 times x is 1x, or we can just write x for this sake. Then we cross multiply. And again, doesn't matter which way you write it. Times, you can do 120 first, or you can do 3.2808 first. Times 120. What do we get when we do 3.2808 times 120. We get 393.696, so we could say 394 meters. X equals, feet. 394 feet. So if you want to create a soccer pitch, you want it to be legal length and width, you don't know how to figure out meters, you can convert it to feet. It should be 295 feet by 394 feet. There we go. The next example, tells us to convert lengths. So here we are converting, the other one was lengths too. We're converting, a car travels 120 kilometers. How many miles is that? A piece of paper is 21.6 centimeters wide. How many inches is that? All you're doing is setting up your need and know. Same thing, you're going to look to what the conversions are, and you don't have to have these conversions memorized. Again, remember, you don't have to know that 1 meter equals 3.2808 feet. That would be given for you. And the beautiful thing is, if you are given a recipe, and it's written in grams and you want it in, you can look up online. You can look up how many, and it will find that conversion for you. The beautiful thing about 2025 is we have knowledge at our fingertips, and it can do conversions for us. But this way, if you're stuck and you don't have it handy, maybe somebody will know, and then you can set up these ratios. Because it's still just cross multiplying, I'm going to skip this and go to the next slide. And if we have time, we'll come back and we'll finish these examples. Let's look at metric units of weight. The metric system of measurement uses the mass units. So here we have grams that we were talking about, kilograms, and ton. We got into it yesterday. We know that this is the metric system of measurement for mass. Much like yesterday's graphic, we have here the conversion of weight in the metric system. Remember, it's based on units of 10. So when you are going from large to small, you're going to multiply. And when you go from small to large, you divide. And based on either the prefix, remember kilo is 1,000, centa is 10, deci centa is 100, deci is 10. We can follow the steps, if you will. So here, if you're going from gram down to milligram, it's 2 steps. So from 100 to 10, and vice versa if you're going the other way, from gram to kilogram. Kilo is 1,000 to 10. Each one, depending on the step that you move, lets you know how many spaces you're supposed to move. Here we have a practice question that says convert each weight, 2.15 kilograms to grams. Well, we are working within the metric system. Kilograms is metric and grams is metric. So we don't have to memorize or know what the conversion is. We are just going to work off of our units based on those tens. So 2.15 kilograms to grams. We're going from big to small. And if you remember, we had our little cheat sheet that says small to large. We're going to divide, and that means we are moving to the left. When you go from large to small, you are going to multiply, and that means you're moving your decimal to the right. So keeping that little cheat sheet in mind, we're going from large to small. So we want to multiply. And what are we multiplying by? Well, you can go through your steps, or again, we know that kilo is 1,000. So we're going to multiply by 1,000. Here I have 2.15 kilograms. When I'm multiplying, I can move my decimal to the right. And there are 3 zeros in 1,000, so I'm going to move 1, 2, 3 spots, meaning that I have 2, 1, 5, and then a decimal over here. Remember, I can't just have a floating decimal. I can't just push that decimal to be 215. I need to include, and I'm going to see if I can do this in a different color. I'm going to need to include that placeholder, which means that 2.15 kilograms is 2,150 grams. They are all grams to kilograms or kilograms to grams. So let's do C. Let's go down for time's sake. And we're going to say 197 grams. Actually, let's do the one beside it because then I don't have to squish my writing. Here we have 12,670 grams that we want to convert to kilograms. Now we are going from a small unit to a larger unit. When we go from small to large, we want to divide, and we have kilo again, which we know is 1,000. So we're going to divide by 1,000. When we divide, we're moving our decimal place to the left. So 12,670 is like 12,670 decimal 0. And we're moving our decimal place to the left 3 spots because there are 3 zeros in 1,000, or 3 steps to get from kilogram to gram. So we move to the left 1, 2, 3 spots, putting our decimal 12.670, or just 67. Now you don't need that placeholder at the end. You can just leave it as 12.67 kilograms. Always include those units of measurement. When you are given your questions, you want to be paying attention to the units of measurement so you know what system of problem solving to use. If my units of measurement are all within the same system of measurement, whether imperial or metric, then if it's metric, I'm moving decimal places. I'm using this cheat sheet here of small to large, divide, go to the left, large to small, multiply, go to the right. I'm going to use that system because I'm working within the metric system. If I have to go between, so you're looking at, you're reading, is it kilograms to grams? Those are both metric. I can use my decimal system of moving. If one is metric and one is imperial, then I need to set up my ratios. Here we have more converting practice, converting each weight, but it's not just all by 1,000. So let's try some of these for practice. Here it says convert each weight. We have first one is 65 grams to kilograms. So we've been doing that one. That one we can just do quickly. We're going from small to large. We're going to divide. Kilos 1,000. So we're going to divide by 1,000. 65 means we're moving to the left. 1, 2, 3. Putting in that placeholder. So 65 grams equals 0.065 kilograms. Now the next one, 2,000 milligrams to grams. Milli also means 1,000. We can think of it as killa, milla. A millipede has 1,000 legs. A centipede has 100 legs. So milla is also 1,000. When we're going from small to large, we are going to small to large, you divide, but here we're going from large to small. So we're going to multiply by 1,000, and we're just moving 3 spots. So of 2,000, we are moving to the right. No, we're dividing. Milligram to gram. Silly. Silly Kobe. Wah, wah. Milligram. 1, 2, 3. 2 grams. Ton to gram, we're going from large to small. So this one we're going to multiply by, and if you look, let's see if I can find my, here we go, ton to gram. You can see on our visual, see milligram is down here and gram is here. We are going to go from ton to gram. So we move, here we have the times 1,000, going from a ton to a gram. Multiply 1,000 to kilogram, multiply by 1,000 to gram, multiply by 100 to centigram, multiply by 10 to milligram. So you're just following the steps. The other way it can be written, like we had with our other version, we had ton. Well, oh boy, let's try. Slow down. Ton, there we go. Kilogram. Gram. Centigram. Milligram. And if you remember how we had our first step was the small, and then centigram went a little bit larger, gram was larger, kilogram longer, larger, and ton, there we go to the end. So it was climbing those steps to get to. So you can either use the number line visual of across and jumping, or you can use the steps visual of climbing up or down. Back to our question. All right. Those ones were all within the metric system, so we can practice those later. Let's move on to metric units of capacity. I just want to make sure that we get everything in because this lesson should wrap up today so that tomorrow we can get into 14 and stay on track. Metric units of capacity. Capacity is a measure of how much liquid a container can hold. When we're thinking of capacity, we're talking liquid and how much can a container hold of that liquid. When we are talking about conversions from imperial to metric, the imperial units are fluid ounce, pint, quart, and gallon. In the metric system, we're using milliliters and liters essentially. So if you need to convert from imperial to metric, we have 1 fluid ounce is equal to 28.413 milliliters. One pint is equal to 0.568 liters. A quart is 1.1365 liters. A gallon is 4.546 liters. So then vice versa, if you want to know how much a milliliter is, it's 0.0352 fluid ounces. 1 liter is 1.7598 pints. 1 liter is equal to 0.8799 quarts. And 1 liter is 0.22 gallons. Just like we learned for length and mass, when we are working within our own metric conversion, it's based on units of 10. So we have the liter. From the liter, smaller is centiliter and milliliter, larger is a kiloliter. And you do those units of 10. So going from a kiloliter to a liter, when you're going from big to small, you're multiplying by 1,000. From liter to centiliter, you are multiplying by 100, and then centiliter to milliliter is by 10, and vice versa. When you go from small to big, you divide. Let's practice. Here we have converting each capacity. You can see it's milliliters and liters that we're working with, so we're working within the metric system. That makes it easy for us because we are just using those units based on 10, and we don't have to worry about finding what the crossover is, so to speak, from imperial to metric. So when we are going from milliliters to liters, we're going from small to big. When we go from small to big, just like in our other units of measurement, we are going to divide, and we're going to divide by 1,000. So we're moving our decimal place to the right. We're dividing. 1,965 milliliters is equal to how many liters? We're going from small to big. We are dividing, so we're moving our decimal place to the left. We're moving it 1, 2, 3 spots to give us 1.965 liters. The next one is going from liters to milliliters. We have a large unit going to a small unit. When we go from large to small, we need to multiply. From liter to milliliter, we're going to multiply by 1,000. When we're multiplying, we're moving to the right. So 19.1, 3 zeros, 3 steps. We're moving 1, 2, 3 decimal places. So now you can see we need to put in those zeros as placeholders, and we end up with the 19,100 milliliters. You're just finding, am I going from a bigger unit to a smaller unit? If so, I need to multiply, but if I'm going from a smaller unit to a larger unit, I need to divide. Dividing means I'm moving the decimal to the left. Multiplying means I'm moving the decimal to the right. If you want to keep practicing, you can. But we're going to keep moving on, and we're going to practice in between. So what I should do is I should show you. Here are the other questions. Convert 107 milliliters to liters, and question D is convert 0.9 liters to milliliters. So a lot like our support questions, if you feel like you're getting the hang of it, we can just move on. If you aren't super confident yet, you can pause and go back and try more questions. Let's practice converting in between the two systems. Here we have convert each measure. A container holds 5 pints. Convert that to liters. So we know pints and liters are a mixture between the imperial and the metric. So what we want to do is find out what is the conversion. We need to set up our know and our need. Because we're dealing with pints, we're going to put pints on the top. So we have 1 pint is equal to 5 pints. I don't know why I said points. We set up what we know on the top. When in doubt, set up ratios, put what you know on top. So 1 pint, because we're dealing with pints here, we're going to put pints on the top. So 5 pints. And our know is we look for how many pints are in a liter. Over on the side, I've done the research, so to speak, for you. It's from our book. 1 pint is equal to 0.568 liters, and that's our unknown. We don't know how many liters 5 pints is going to be, so that's our x. And then we just cross multiply. So 1 times x is 1x. 5 times 0.568. We're going to calculate what is 5 times, I did divide, 5 times 0.568. That means x equals 2.84 liters. Therefore, 5 pints is equal to 2.84 liters. Or you can say a container that holds 5 pints is equal to 2.84 liters. You can write your therefore sentence however you like, but make sure that if it's a word problem, it has that therefore sentence. And it's always a good habit to write one. The next question says a gas tank can hold 80 liters. Convert liters to gallons. So again, we're going to set up our ratios. Something equals something. The liters is what we're dealing with. So 80 liters is going to be our need, which means 1 liter is our know. How many gallons? So we look at 1 liter is equal to 0.22 gallons. And then we don't know what those gallons are going to be. So we have 1 over 0.22 equals 80 over x. And now we cross multiply. We go from our 1 down to our x, which gives us 1x, or we can just say x. And then we cross multiply 80 times 0.22. And we can just type that into the calculator, 80 times 0.22. We get x equals 17.6 gallons. And do your therefore statement. Therefore, the tank can hold 17.6 gallons. When it's between the different measurement systems, you have to set up your ratios. All right, how many more slides should we get through? All right, we're going to skip these practice questions. If we have time, we'll come back to them, but I want to make sure we get all of our information in. If we don't have time to come back to them, you can maybe pause this recording, try your hand at converting each measurement, and you can always go online and see if you're right. You can always type into an online tool, what does 4.2 fluid ounces of perfume convert to in milliliters? What does 40 gallons convert to in liters? To check to see if you're right. The next question, a can of pasta and tomato sauce contains 398 milliliters. Convert that to fluid ounces. But we are going to go on to talk about the imperial system. We know that the metric system is based on units of 10. Now the imperial system has the basic unit of length, when we're talking length, is 1 inch. each inch is divided up into 16 equal parts. So 1 part is 1/16, 2 parts is 2/16, and that can be reduced to 1/8. The most common units of measurement in the imperial system are inches, feet, yards, and mile. And it's good to know this to familiarize yourself with the different units so that if you come across a question, you'll know, oh, hey, wait a minute, that's in the imperial system and that's in the metric system. And you'll know then that you have to set up your ratios. When we are looking at metric versus imperial, when we talk about the standard unit for measurement of length, in the metric system, we're talking meter. And in the imperial system, we're talking mile. Now, it's really easy to know the metric system because, like we said, our prefixes, it's meter, and then you either go smaller to centimeter, decimeter, millimeter, where if you need to go larger, it's kilometer. You're just adding those prefixes in front. But for the imperial system, it is a little bit harder. Like we just talked about, the measurement of length can be inches, feet, yards, and mile. It's not as nice with the prefixes and not the suffixes, just the prefixes. When we are looking at weight, the standard unit of measurement for weight is the gram. And so you've got the kilogram. When we're talking about the standard unit for measurement of weight in the imperial system, we're talking pound. In the metric system, if we're measuring capacity, the standard unit is liter. In the imperial system, the standard unit is gallon. Now, the one time everybody agrees is when we talk about time. When we're measuring time, it doesn't matter if we are talking metric system or imperial system. Everybody uses hours, minutes, and seconds. So that's one thing we don't have to convert. To lay it out for you, we can see here that the metric system is based on the decimal system of units, based on meters, kilograms, and second as the units of measuring length, mass, and time. Imperial system, it's a system of measurement used in countries like the US, Myanmar, Liberia, etc. They include units such as inches, feet, and pounds. Metric units are in powers of 10. So 100 centimeters in 1 meter, 1,000 grams in 1 kilogram. There's no specific pattern in the imperial units. That makes it a little bit harder to convert between if we were to do that with the imperial system. We only focused on metric system because that's what we use here in Canada. Metric system units, we have centimeters, meters, grams, centigrams, liters, kiloliters. Imperial units, inches, feet, ounces, pounds, miles. These are common terms for the different units. When you are thinking of lesson 13, and we are talking about imperial and metric measurements and the conversions, it's good to have that history. Why is it that we do what we do? Why is it that we are one system and other countries are another? Why is there those differences? You can keep in mind that the metric system was first introduced in Canada in 1871. But it took a long time for us all to be on the same page. When we're talking metric system, it is used to measure objects according to length, weight, volume, or time. Imperial system does that too, but the metric system is based on the decimal system as it includes numbers in powers of 10. If you need, you can always reach out to me with any questions you might have. You can go back and watch the recordings. They are posted to our WASA YouTube channel. And I do encourage you to be working on those assignments and submitting them as you complete them so that we can make sure you're on the right track and you don't have to redo a whole bunch. Nobody wants that. I hope you have a great rest of your day. Tomorrow we are broadcasting for the last day of the week. We've made it. One more class this week. Enjoy. Take care. See you back.